Let's start the Hadoop HDFS practicals. Before going to start this Hadoop HDFS practicals, we have to learn some internal concepts. Let's have the look up about heartbeat mechanism and checkpoint mechanism. Here the checkpoint mechanism and heartbeat mechanism will works in the internally with the Hadoop cluster. And suppose let's have an example. Whenever we are doing the actions in the name node. Fine. Here before going to pertain this action, the job tracker in name node will always checks that the task trackers are available in the respective data nodes. To checking these things, and after modifying all the file modifications, we have to update the namespaces like FS image and edit log files, fine, which are containing the metadata information. This updating metadata information in FS image and edit log files in a periodical manner, this entire mechanism we are calling as a checkpoint mechanism. Updating metadata information in a periodical terms like hourly basis, weekly, monthly, whenever we are maintaining the things, it will be updated frequently, periodically. This entire mechanism we are calling as a checkpoint mechanism. In the entire cluster we already have some checkpoint node which is taking care of updating a namespaces, fine. And after, let us have a look about what is heartbeat mechanism. Here whenever we are performing an action from the name node, the job tracker in name node will always expect say acknowledgement from the task trackers which are residing in the data nodes. Why it is expecting a acknowledgement means it should know as a name node what all the data nodes are available to perform an action. Suppose suddenly a client may raise a request, means it should serve the request and it should be executed based on by taking the help of available data nodes. To check what are all the data nodes are available, it take the help of these acknowledgements which are getting from the data nodes. And here majorly we are talking about this getting the acknowledgement from the task trackers which are residing in the data nodes to the job tracker which is residing in the name node. This concept we are taking as the heartbeat mechanism. Okay, suppose any one of the data node is not giving a proper response. Maybe it may be a data node failures, maybe a network glitches, maybe the entire node is going to shut down. Based on these categories, these issues, maybe the data node may not be sends the acknowledgement. For this kind of things, suppose let's have a look here. Suppose I am storing a action, I am storing the file kind of myfile.txt. If you are containing this, suppose if you have this, take this myfile.txt as contains 100 MB of a size, means it should maintain at least 2 blocks, fine, B1, B2. B1 has copied in the data node 1 and B2 has copied into the data node 2. Whenever we have to execute, whenever we have to retrieve the entire information about myfile.txt, as the name node will ask the data node 1 and data node 2 to get the information about B1 and B2 blocks. But suddenly when the data node 2 is not working, whenever we are executing the client request, suddenly the data node 2 goes down. At this time it should be maintained, we should take the metadata information of a block 2 and check out what are the remaining data node replication of data is there. It will goes to the data node 3 or data node 4. Other than data node 2, it should be gone and it will be checked out. This entire mechanism, suppose one data node is failure, means we have to hand over this entire task to the another data node which has the B2 block is there. This mechanism we are making the sense like speculative execution. The speculative execution is a term which refers when the data node is suddenly not working or based on the network glitches or some network related issues, or maybe it may get down, then it should be as a name node, it should hand over the entire task of the data node to another but available data nodes. This entire task we are making the sense as speculative execution. I hope you got the examples of these heartbeat mechanism and checkpoint mechanism and the speculative execution. and based on the remote procedure calls and maintaining these terminologies, we have to execute all these actions. I hope you understand what are the internal actions which are performing the HDFS, and it's time to enter into some Hadoop environment in real time. And I already given that how to install a Hadoop cluster and Hadoop software in a pseudo distributed mode. Here you may have the look about how to log in, how to open a Hadoop cluster. And here we have some however we are working with any operating system, the Hadoop will only works with the Linux, Mac and Windows and Sun Solaris. Only in these 4 operating systems only we are able to work with the Hadoop cluster. And suppose if you are working with the Windows and if you want to make use of things means also you can install the Hadoop cluster and all things, but preferably I am recommending to work with the Hadoop means make sure that you are working with the Linux. In the real time also in the production systems we are installing the Linux, any one of the Linux version like Ubuntu, CentOS, Red Hat, any one of the Linux version, and you are able to execute our Hadoop environment. Here I am using a Linux environment as a Ubuntu operating system, and here I have created one virtual image by taking the Ubuntu operating system image, and I am going to execute our operations. I already given this link Ubuntu drive to all your email IDs, and here let's have a look how to work with the Linux operating system from the Windows with the help of VMware workstation. I hope you guys will know that what is the importance of VMware. Okay, and here let me open a virtual image. Here we have something. After opening the virtual image file, we have some power on this virtual image button is there, right? We have to click on this, then we are able to work with that virtual image which has the Hadoop cluster. Here I have installed the Hadoop cluster 2.x. I have 2 images. One is work with the 1.x and one is work with the 2.x. I will help you to how to understand internal architecture of 1.x and 2.x also. Let's have a look. Here is the Ubuntu desktop which you are working with our Hadoop environment. And before going to start anything, let's check the things like, as the Hadoop, if you want to check that if the image is having the Hadoop image or Hadoop software or not on anything, means we can simply check by using version command. It also gives the, if the Hadoop is already installed in this your operating system, means it gives the version information, which type of version you are able to work with the Hadoop environment. And if it is not there, if your Hadoop is not working with your image, means it will give you that clearly the Hadoop is not installed. Hadoop is undefined command in our operating system. Let's have a look which type of version I have in Hadoop, as I already installed in our Ubuntu operating system. Here you people may understand that Hadoop, I am working with the Hadoop 2.x, the latest version is Hadoop 2.6.0. Fine, you can also get it from the Cloudera environment, which is installed from the things. And here, before going to execute the things, I will check it out. Before here, we have three things are there. Before going to discuss, we have to discuss about Hadoop environment modes also. Fine, here we have three kinds of modes are there. Those are standalone mode and pseudo distributed mode, and we have fully distributed mode. We have three kinds of distributed modes are available to work with the Hadoop environment cluster. Here the standalone mode, which execute all the daemons, all the name node images like name node, second node, everything will be work in the single JVM itself, and it is nowhere we are using. If you are as a simple purpose itself we are working, you can able to install this Hadoop as a standalone mode. And here if you want to work with the pseudo distributed mode, here what we have to execute the things means, here in the pseudo distributed mode, every data node, like every daemon will install in a separate JVMs. Fine, here as a pseudo distributed mode we have to work with the everything. Here we have the as a Hadoop, we already defined that Hadoop daemons like name node, data nodes, job trackers, secondary name node, task trackers as in 1.x. In 2.x we have other daemons. Each and every daemon will have a separate JVM to work with the environment. And here as explanation purpose itself, I am also executing the task in a pseudo distributed mode only. In this my system has also installed the Hadoop within the environment like pseudo distributed mode only. Then what about the production environments in the real time, means it have the term like fully distributed. What is called this fully distributed mode means, here each and every daemon will have a separate JVM and it has a separate distribution mechanism software, like it has some individual nodes maybe we have to maintain. This entire concept we are saying as a fully distributed mode. Here only the thing is in individual data nodes and individual respective cluster nodes, the JVMs will be installed and individual JVMs will have the individual respective daemons, Hadoop daemons. And here this is about standalone, pseudo distributions and fully distributed modes. And let's come back to our Ubuntu image. Here if you want to better understand about this Ubuntu and all the things, I hope you guys will understand this is a Linux operating system. And here let's zoom up the things. I hope you are able to see that screen. And you people know have that basic commands, Linux commands, like if you write some ls means it will give the listing of all the directories and files. Suppose I have these many files are there in our Hadoop environment. Okay, let me create one directory with my name, something like with our Hadoop software, as this is first directory. This is the first directory I am able to create. See, CD is used to change directory. If you want to create a directory, means before going to move the first directory is not there. For that purpose itself we have to create it, mkdir, which is used to make a directory. and we have to give the file name as first directory. It is successfully executed. Let's check the ls whether first directory is there or not. Fine. And suppose if you want to enter into the first directory, we have to use the command like change directory, cd space first directory. Now I am in first directory only. Fine. Now you people know understand what is the difference, what are the Linux commands are there. That's the, like, we are working with the Linux environment, you need the basic recommendations from the Linux commands. I hope you guys will have the ls, and if you want to create a file, you have to use some files. Let me check it out. Let me create one file in Linux environment before going to take that out. And here we are executing the Hadoop distribution files, right? Fine. Here if you want to execute these Hadoop file commands, means the basic thing we have to maintain are the necessity softwares we have to install. And here yours the Linux means we have to maintain everything will be the recommendation should be in the client command line interface only. Here we have, let me create one file with the help of vi editor. I hope you guys will know. Let me create one first.txt. I am creating one textual file. It already opened. It is ready to take the content. If I press the insert, this is first file in Hadoop. That's what I want to copy. :wq, which already saved the file. Let's open the first.txt. Yes, I have a content. This is first file in Hadoop environment I created, and let's figure out where it is stored. Yes, in the first directory only. In the first directory, the file I created is first.txt. Fine. If you want to remove this file, means we have rm command is also there. You can check it out the remaining files, remaining Linux commands. We have a lot of the things are there to check the word count, wc. We have some grep command is there in Linux. And if you want to take this help of, if you want to check this, if you want to change the permissions, we have chmod and chown commands are there in Linux, and the default permission levels are 644, as mean read write as a user level, and only read permission for group level, and read level for others remaining things. And here the main thing we have to learn about the things is we have a ll command is also there to check the complete information about a file. Here check it out. Here if the first character is having the d, means it is a directory, it is not a directory. Y means the first.txt is a file. Fine. If you want to move back, means I can also press cd space ... Now check that what are the files are there. If you keep enter ll, means we may have the complete information. We have all these things as a directories which have the starting character is d. Fine. The remaining or the permission levels, we can also change these permissions by using command called chmod. Fine. But defaultly it has the permissions levels as read write and read. I hope you understand the basic Linux commands. Let's enter into the Hadoop environment. If you want to enter into a Hadoop environment, we have a basic command we have to type is Hadoop fs is the basic command, basic starting command to work with the Hadoop. And we have seen lot of Linux commands, right? Based on these Linux commands only, similar to these Linux commands only, we have to work with the Hadoop commands. Let's check it out. To get, first of all, as the first command, if you want to get out what are the Hadoop commands are there in our Hadoop cluster, Hadoop environment, you have to know. Okay, for that purpose we have to use the term like -help. And don't forget guys, here as the Hadoop command, as the first letter is a hyphen. Each and every Hadoop command has a hyphen symbol to represent it is a Hadoop related command. Let's check it out. -help will gives the complete structure of Hadoop commands. Fine. We have a lot of commands are there. Here you can easily represent our Hadoop cluster. C, append to file, and cat. In C, in Linux, however, we are using cat as a if you want to find some content about a file, means we are using cat. In the same level here also we have to use it. And to change the group level permissions, we have to use chgroup. If you want to change the entire permission, file level permissions, we have to use chmod. If you want to change the owner of a file, we have some multiple users are working with some production environment. If you want to change the owners, means we have to use the ch1. Like this, we have lot of commands are there. cp we have, means cp is used to copying the files. I will tell you, copy from local, copy to local is very important commands. I will tell you one by one. We will check all these commands. First of all, as the basic command to check to list what are the contents of a directory, means we have to use -ls. Let's check it out. As the basic thing, Hadoop FS. We want to work with the Hadoop file system, not the current Linux file system. For that purpose itself, I am mentioning Hadoop file system, Hadoop FS, and I want to list what are the files are there. Here, check it out. It is trying to fetch all the content about Hadoop file system. Here only you have to get one major important thing is it is unable to load the native Hadoop library. What is the reason we are unable to load the Hadoop environment now? Actually, Hadoop is working. We have a Hadoop. We already checked it out. Hadoop version. We have a Hadoop in our operating system, that is Hadoop 2.6.0 version, but I am unable to unable to execute the Hadoop commands. Why? Means we didn't start the daemons. To check what are the processes are executing in a Linux, means we have to use the command like ps. Here we are working with the command line command interface, and we are working with the bash terminals and ps terminals. And here let's check it out. If you want to work with what are the Java processor there. Suppose we have as a Hadoop, it maintains some daemons, right? We have like that. As a 2.x, what are the daemons we have to maintain? Name node, secondary name node, data node, resource manager, and node manager. We have to execute and we have to up and run all these daemons to work with the Hadoop. Let's check it out. And our Hadoop software is written in a Java. For that purpose itself, this entire daemons also work with the backend program with the help of Java programming language only. And these are the Java processors. To check what are the Java processor executing, means the command is JPS, Java processors. Fine. Here the Hadoop daemons also is a Java processors to check the JPS. Let's check, guys. We don't have the up and running with the name node and data node and remaining daemons. To start all daemons in a Hadoop environment and Hadoop cluster, means we have to use the command called start all.sh. To start all the daemons of a Hadoop cluster, we have to use the start all.sh. To stop all the daemons to work from the Hadoop environment, we have to use the we have to use the file. We have to execute the file called stop all.sh. And as a start all.sh internally executes a start dfs.sh, which contains the data file system called data node name node and data nodes and secondary name node. Fine. Here you can able to see. Fine. As the storage components, if you want to start the storage components, means we have to use start dfs.sh also. And if you want to execute MapReduce related and yarn related processing daemons, means we have to execute start yarn.sh. And if you want to execute all the Hadoop daemons, you can simply use start all.sh also. Check it out, guys. It is starting the name node, and we done with the data node, and it is ready to start the secondary data node, secondary name node. We done with the storage daemons. Now it's time to execute a yarn related daemons. The Hadoop itself it will be executed. Here we have a AND daemons like resource manager, which is residing in the name node, and node manager, which is residing at the data node. All the daemons will be executed. Let's start with. Let's check it out whether these Java processes are up and running or in our live cluster or not. Yes, we have resource manager, secondary name node, node manager, data node, and name node. All the daemons are working with now. Now check it out whether I can execute the Hadoop commands or not. To clear the screen, we have a Control plus L, and we have a clear also. We type the clear also, and here as the basic thing, let's check it out. To list the what are the directories in a Hadoop, we have a command called Hadoop FS -ls. If you want to check what are the files are there in a root folder, let's check it out. What are the files are there in a Hadoop root folder? It is trying to fetch the what are the contents are there in that. It should execute it. Why means we already started the all daemons of a Hadoop. For that purpose itself, we are executing this. We found the two files, which is /tmp and /user. This is driven by the Hadoop environment itself. Let me create your own file, your own folder. Fine. The thing is, how to create a folder means we have a Hadoop FS as the basic command, and to create a Hadoop directory, HDFS directory, we have to use the command. Same thing in Linux means we have a command like mkdir. Here we have to use hyphen, similar to the Linux commands only. Mkdir space, we have to give the folder name. Suppose I want to give HDFS folder. HDFS folder 1. I just created a folder like with the name like HDFS folder 1, and here check it out whether the folder is there or not. How to check that? We have already have the ls command to check whether the file is, whether the folder is there or not. Yes, we have the things like we have listed the file like HDFS folder 1. Fine. Then here we have to check it out. Here we have to copy the files, as the HDFS is meant for storing of a large files as a basic thing to store a files. Let's have a thing like how to copy a file into a Hadoop environment. We already seen that